Okay, so this is part two of simplifying expressions that have rational exponents. Now, again, we're going to be dealing with positive rational exponents. So our exponents will be positive. Now, remember in the previous lesson, we learned this. So just as kind of review. So we saw how to deal with 8 to the 1/3. So we know now what this means. So in the previous lesson, we used a definition that said that a to the 1 over n is equal to the nth root of a. So your base here, when you rewrite it in radical notation, this is radical notation, your base becomes the radicand, and notice this is 1 over n, so your numerator is 1, and so your denominator becomes your index. So the nth root of a. Now, so in this case, 8 to the 1/3 will become the cube root of 8. So that's your radical notation. And then that simplifies to 2. Because remember, cube root of 8 means what number times itself 3 times is 8. So the answer is 2. Okay, but now we want to talk about, well, what happens if this was, let's say, 8 to the 2/3 instead? All right, because that definition here applies if my numerator of this fraction is a 1. So this numerator is no longer a 1, it's a 2. So let's look at let's determine what to do using this idea. All right, so we know that 8 to the 2/3 is the same thing as saying 8 to the 1/3 raised to the second power. And it kind of makes sense because you remember in a previous lesson, the power rule said that when you have a power raised to a power, you multiply the powers. So 1/3 times 2, 1/3 times 2 is 2/3. Okay, so that's still true. And then here, notice right here, this right here, I can now use this definition. So that's going to be the cube root of 8, all raised to the second power. So notice 8 to the 1/3 is this. So I can use this definition. So I can rewrite 8 to the 1/3 using radical notation. And my exponent is 2. And I know that the cube root of 8 is 2. So this is 2. So I get 2 to the second power, which is 4. Okay? So I get 4 there. Okay, so let's look at the definition now of this. So the definition of a to the m divided by n. So it's no longer 1 divided by m, it's m divided by n. So we're kind of expanding this to rational exponents that no longer have 1 in the numerator. Okay, so based on what we did, based on this right here, a to the m over a raised to the m divided by n is going to be the same thing as the nth root, using this right here, the nth root of a, that's n right here, the nth root of a, all raised to the m power. Okay, so the cube root of 8 raised to the second power, so the nth root of a raised to the m power. All right, or you could do this as well, is the nth root of a, and then instead of raising this whole thing to the m power, you can raise a to the m power. Okay? All right, so for example, let's go back here. I'm going to show you how this and this are the same thing. Let's go back to this one right here. So we know this. We know that I'm going to write this here. So we know that 8 to the 2/3, 8 to the 2/3 means the same thing as the cube root of 8 squared. All right, that's this right here. So the cube root of 8 is 2, so 2 squared is 4. What I want you to understand is this, though, that the 8 to the 2/3 is the same thing as saying the cube root of 8 squared, like this. So you're squaring the 8 instead of squaring the cube root of 8. So look to make sure it makes sense. So there's a cube root of 8 squared, 64, and then you ask yourself, well, what times itself 3 times is 64? Well, the answer is 4. 4 times 4 is 16, 16 times 4 is 64. Now, here's what you understand. It is easier, most times it is easier, instead of putting the exponent under the radical, it's easier if you leave it on the outside. All right, so this right here is the easier notation. This is easier to use. Easier to simplify, I should say. Simplify. All right? So most of the time you'll see, when you simplify, you'll see it written like this rather than this. Because here you gotta raise a to the m power, and then you gotta figure out what the nth root of that is. Okay? So your notice this, your radicand here is smaller than this radicand. Okay? So it's easier to simplify a radical expression if the radicand is smaller. So that's why this one's easier to do. Okay, so all right, so also keep in mind that when using this definition, just like when using this, remember we said that n here must be a positive integer greater than 1. So here, m and n must be positive integers. If I'm using this definition here, right here, m and n must be positive integers. Must be greater than 0. Okay, also n must be greater than 1. Okay, so you want n to be bigger than 1. All right, now if m is 1, if m is 1, it brings us back to this. All right, but remember, n must be bigger than 1. It's got to be, this denominator here must be 2, 3, 4, 5, 6, and so on. Okay? All right, so let's look at some examples. So let's simplify each of the following. Well, actually, directions will say this. Directions will say, use radical notation to write the following. Use radical notation to write the following. And then simplify if possible. Okay, so it's very simple. If you can do the previous lesson, this is basically the same thing. Okay, number 1. Suppose we had 4 to the 3 halves. All right, so remember your by definition. Remember our definition, and I'm going to use the one where the exponents will be on the outside. So by definition, a to the m divided by n, I'm going to say that's going to be the nth root of a all raised to the m power. Okay, so notice the denominator is your index and your numerator is your exponent. So your numerator is your exponent, the denominator is your index, and your base becomes your radicand. Okay, so by definition in radical notation, that's going to be the square root of 4 all raised to the 3rd power. So that's your radical notation. That's radical notation. Make sure you understand what to put in the blank for radical notation. It's got to be this. Now simplifying is going to be this. The square root of 4 is 2. 2 cubed is 8. So that's your simplified answer. Simplified. All right. Number 2. Suppose we had negative 16 to the 3/4. Negative 16 to 3/4. Now notice there's no parentheses, so remember the only thing being raised to the 3/4 is the 16. So this is going to become negative 4th root of 16 all raised. Now notice I only have the 4th root of 16 in the 4th root of 16 in parentheses, and that's being raised to the 3rd power. Okay, so that's your radical notation. That's going to be your radical notation. That's what you put in the blank. Now we're going to go ahead and simplify this. All right, so first of all, the 4th root is 16. What number times itself 4 times is 16? The answer is 2. So this becomes negative 2 cubed, and then 2 cubed is 8, so it becomes negative 8. So that's your simplified answer. So simplified. Okay, so that's going to go in the blank, negative 8. So the one that goes in the blank for radical notation is this. The one that goes in the blank for simplified is negative 8. Number 3. Suppose you had negative 27 to the 2/3. Notice this time negative 27 is in parentheses, whereas in number 2, negative 16 was not in parentheses. So your base here, the only thing being raised to the 3/4 was 16. So here it's negative 27. So this becomes the cube root. So remember your index, your denominator becomes your index. So it'll be the cube root of negative 27, all raised, make sure you put that in parentheses, to the, and the numerator becomes the exponent. And then just kind of, so that'll be your radical notation. That's your radical notation. Now let's simplify. So the cube root of negative 27, so what number times itself 3 times is negative 27? The answer is negative 3. But remember, that's being squared, so that's going to be 9. So that's your simplified answer. So in the blank for simplified, you're going to put 9. Sorry, you're going to put 9. So the cube root of negative 27 is negative 3. Negative 3 squared is 9. All right, number 4. Suppose you had, all right, let's suppose you had 1/9 to the 3/2 power. 1/9 to the 3/2 power. Well, by definition, that's going to be, using the definition, that's going to be the square root of 1/9. All that's being raised to the 3rd power. So that's your radical notation. So that's what you put in the blank. Now let's simplify this. First of all, the square root of 1/9, what number times itself twice is 1/9? Well, the answer is 1/3. So the square root of 1/9 is 1/3, but remember that's being cubed. And so 1/3 cubed means 1/3 times 1/3 times 1/3, which is 1/27. So this right here is your simplified answer. So in radical notation blank, you'll put this. In simplified blank, you'll put 1/27. Number 5, let's suppose you had, now sometimes they'll have this. Don't make it too difficult. This is what they'll have. So you have this expression, raised to 3/5. Just use the definition. So it's going to be the 5th root of 4x minus 1, all raised to the 3rd power. And there's nothing you can do. You don't know what x is, and there's no way you can write this as something to the 5th power, so leave it as that. So that's going to be your radical notation. And then in the simplified blank, if the direction says, on MyMathLab it may say cannot be simplified. So if it says that, then say can't be simplified. And I think on the worksheet it may say that also. So if it doesn't, then on the worksheet where it says simplified, you can just put this answer back. So it'll be the 5th root of 4x minus 1 cubed. But I think it may say, write it in radical notation, simplify. If it cannot be simplified, say can't be simplified in this blank. All right, so just look at the directions. All right, number 6, suppose we had negative, in parentheses, 81 raised to the 3/4 power. So notice this kind of looks like number, which one was it? Number 2. Kind of looks like number 2. Number 6, except this time they put in 81 in parentheses. They didn't have to. They could have said negative 81 without parentheses raised to the 3/4. But just notice the difference between these two. So don't let that confuse you. The only thing being raised to the 3/4 is 81. So there's a negative out there. So notice the difference between number 2 and number 6. So don't let that throw you off. So that's going to be negative 4th root of 81. And that 4th root of 81 is being cubed. So this is your radical notation. Now let's see if we can simplify this. So that's going to be negative, the 4th root of 81, so what number times itself 4 times is 81? So let's try 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So we get 3 cubed. And so that becomes negative, and then 3 cubed is 27. So that becomes negative 27. So that's your simplified answer. Okay, so let's look at this. Let's look at one more, 7. Suppose we had 1 divided by 25 raised to the 3/2. So again, don't make it difficult. That kind of looks like one we did earlier, I guess number 4. So that's going to be the square root of 1 over 25, all raised to the third power, so that's your radical notation. And then let's simplify. The square root of 125 means what number times itself twice is 1 over 25, so the answer is 1/5, because 1/5 times 1/5 is 1 over 25. But I am cubing this, so 1/5 cubed is 1 over 125. So that's your simplified answer. Okay, and so that was the end of that part. So in this part, what we did was in the previous lesson we looked at the definition a 1 over n, and we learned how to rewrite this in radical notation and then simplify. In this lesson, we expanded it to where the numerator was no longer 1. It was something other than 1, and so we looked at this definition, and it was easier to use this notation rather than this one. Okay, so a to the m over n would be the nth root of a, all raised to the m power. So it's just an expansion of this one. All right, so that was part 2.